Hello all. In this video we'll see deterministic finite automata with Streamlit and Python. So I'm continuing with another journey where we will study regular expressions, then automata theory. So this is a deterministic, we are looking into deterministic finite automaton. So deterministic finite automaton is a fundamental concept in the field of theoretical computer science, because we know that if we don't build upon our conceptual knowledge of computer science, programming becomes tough. But we will go through the process, like how the system works as a computer, like how the computer science programming language exists with the help of automata theory itself, particularly within the studies of automata theory and formal language. It is a type of finite state machine that is used to recognize patterns within input taken from some set of symbols known as alphabets. So key components and deterministics of DFA. So first of all, we have finite set of states. A DFA consists of finite number of steps at any given time. The DFA is one of these states. Initial state, there is one designated start state where the DFA begins with its operation, input alphabet, a finite set of symbols, each of which is recognized by DFA. Transition function, the function determines how the DFA moves from one state to another. For each state and symbol in the alphabet, the function specifies exactly one state which the DFA will transition. The deterministic nature, that is no randomness or ambiguity in state transition, is a key features of DFA. Accept states among the finite set of states. Some are designed as states, accept states. If after processing an input string, the DFA ends in an accept state, the string is considered to be accepted by DFA. Input string, this is a single sequence of symbols from the alphabet. The DFA processes the string symbol by symbol from left to right. Make it as a habit like left to right itself. So in this particular application, we are using Streamlit and our programming language choice is Python. But apart from that, we are also using a library called Graphviz. So Graphviz is a software package used for visualization of graph. As we are creating DFA, we would be using Graphviz, which are data structures consisting of nodes connected by edges. It is particularly well suited for creating diagrams of abstract graphs and networks in variety of style. So if you want to install Graphviz, the command is pip install Graphviz to your command line interface, and you would be able to go with it. So let's take a look at the code itself. We are starting from scratch. My IDE of choice is Visual Studio Code. I'm just opening it up in the folder. Okay, so now what I will do, I will just open up a new file. I'll name it as dfa2.py. Okay, so this is the file that I have created. Now first of all, we'll go through what are the things that we are trying to achieve over the time. So first of all, we are importing Streamlit as ST, as well as from Graphviz we are also using digraph. So I'm not getting into the details of Streamlit because already there are a lot of tutorials available, and you can go through it. And as well as I will be sharing this as a Medium article itself, and I will add it to my video so you can have a look of it. But accordingly, why we are using Graphviz. So from Graphviz we are importing digraph. This line imports digraph class from Graphviz Python library. Graphviz is a tool for creating diagrams and visualization of graphs. The digraph class is specifically used for creating directed graphs where the edges have a direction. By importing digraph, we can create instances of classes in our Python script to define and manipulate directed graphs. We can add nodes and edges to these graphs and customize the appearance. Once defined, Graphviz can render these graphs into visual diagrams. For example, you can create directed graph with dot equal to digraph. This is a convention we use for creating the digraph, and then add nodes such as A for node A and B, A to B, the direction that you want to represent to graph where you are using with arrow pointing from node A to another node. Together we are importing this as libraries. So let's do that. Just import this, both of them over here. So this is the way we get started. We'll just import this, both of them over here itself. Okay. So after that, what we are trying to achieve. Now the next thing is function to create and display the DFA. So the function that we will be creating for displaying the DFA, what exactly it does. It has got a function definition called create DFA, which lists the states, alphabets, transition, start state, as well as the accept state. We initialize the graph using DFA equal to digraph, that is a line initialized as a directed graph, as we have already discussed about Graphviz named DFA. The graph will be used to visually represent a DFA. So after that we add states to the graph. The for loop iterates through each state in the state list. If a state is an accept state, it is marked as an accept state by giving it a double circle. So these are conventions we are using: shape, attributes, double circle. Otherwise it is giving a regular circle shape, as we are trying to replicate a DFA pattern itself. So DFA node adds the state as a node to the graph, marking the start state. So DFA dot attribute node shaped equal to plain text sets the node style to plain text, which is used for the special start state indicator. And DFA node start level equal to the double quotes creates an invisible node to represent the state of the start of the DFA. And start state adds an edge from an invisible start node to the actual start state of the DFA, adding transitions. The for loop iterates over the transitions dictionary. Each key value pair corresponds to the transition in a DFA. So there is a DFA edge, and then we are returning the graph. So again, we'll just go through the patterns of the code itself. Okay. So this is the way we have the DFA created. Similarly, for the Streamlit UI, we are entering the states with comma separated values. We have user inputs, transition function input, defining the transition function, and we are also showing how the transition occurs. Then we have a DFA creation and visualization, the way we are creating the DFA, and that's the way about it. So we will consider Streamlit UI as well as the DFA application. We will just have it handy so that we can get started with it. So that's the way. I'll save it as the entire script is ready. To run the application, what we need to do is Streamlit, then run, then DFA 2.py, and have it working. Just wait for a while to come up. So this is how the entire structure looks like. I have with myself an input pattern that we can put in, like S0, S1, S2, reject. These are the states. So we'll accordingly have the states itself S0, S1, S2 as reject. Okay. Enter alphabet. So what are the alphabets that we would be passing in over here? So here we can say that the alphabet that would go, like the numbers we are associating with it, is 0 and 1. So we'll have it as 0. and 1. Enter. This is the UI for our interface for the DFA simulator. We are giving it the input pattern to get started with. So we have to mention the start state itself. So start state over here is S0. We'll just mention it S0. Enter accept states. So the accept states, we can have it handy with it. So we are considering S2 as an accept state. We'll just put in S2. Now transition, that is happening from one step to another. So transition, this is like according to your what you want to achieve. So the thing is like transition from S0 to S0 on 0, where it is going. We can take it as of your choice. If you want to create a DFA, this is like a convention that I have used. You can follow along. You can create different kind of DFAs. This is an example itself. So from transition from S0 on 0, we go to S1. So we'll mention it as S1. Transition from S0 on 1. When we go to S0 itself. Transition from S1 on 0. From S1 on 0, we go to S1. Transition from S1 on 1. We go to S2. We go to S2. Transition from S2 on 0. S2 on 0, we go to reject state. We'll just type in as reject. Transition from S2 on 1. S2 on 1, that also goes to reject. You can have your logic over here, but as I'm trying to create, I am just following a pattern itself. I kept it as handy. Transition from reject on 0, both of them, the last two options would be on reject. Okay. So we have given all the information that's needed to create the DFA. Let's see that the logic that we have implemented as a code works or not. So as soon as we click this create DFA pattern, you'll see that the deterministic finite automaton has been created, and the steps are being shown for reject state as well as how it goes to the final state, and all the options that's being shown itself. Okay. So that is the way we get started with definite finite automata visualization using Python. If you want to have if you need to have a complete series of entire theory of automata, I can do it. So I need your support. Show me some join my channel so that I can share all of the details. The code for it is also shown over here. I have given the entire code as open source. You can just tweak it around and have it according to your liking. So thank you and happy coding for all of you, so that we can develop much more good things.